Okay, remember, we're really trying to use this to figure out this over here. We're looking for a perfect cube, by the way. And it's repetitive, and that's the problem with it. Before you start, though, I want to point out the lead year is 8 times 10. That doesn't look like times, does it? Times 10. Let me count it up. 1, 2, 3, 4, 5, 6. All right, so if I were looking at that, and let's see what I'd get there. Did I do that right, first of all? 1, 2, 3, 4, 5, 6. And if you took the cube root of this, what would you get? 2 times 10 squared, which is 200. And it's going to match that number there. So if you're starting this thing, what you're going to start out with is 200. What I don't know is what trails it, and that's trouble, right? Now, what do you mean by trouble? After the 200, you get a tens place, then a ones place, then a tens place, so forth and so on. And you got to keep repeating. And you're repeating this thing over here over and over again to make the number smaller and more manageable. And you'll eventually get there. And what would you get to? You'll eventually get to this over here, 200. There will be no tens. And then you'll get 6. And then you get 7 tenths. And when that's cubed, it would give you this number over here. To me, it's numerically a lot of work. What I recommend you do, use Sage and type it in. And appreciate what a burden it was back then to actually do a computation like this. And by the way, in other parts of the world, it's still a burden on kids to do computations like this. And I think that's probably really kind of torture. There should be any more time in problem solving. Because the way it's taught is basically just an algorithm. It's almost like they're learning a song, all right? But they'll get this number. They'll get this in the end. Thank you.